Hello, welcome. This is a full course in the power plant engineering. So I've already covered some videos in the power plant engineering, and this was a series of 10 to 12 lectures, which is again a part of power system engineering. So this is going to be a long video, like it's going to be around 30 minutes or a 45 minutes discussion, even it would go to 1 hour. But right now I'm making the video, I'm not very sure how much long. But if you are into this video, why you should watch this video is that this power plant engineering is part of the basic mechanical engineering courses, and it's also part of a subject which comes as part of electrical engineering. It's usually an optional subject sometimes, or it could be a regular subject. Also, it comes as part of the mechanical engineering. So, power plant engineering is both useful for both the mechanical engineers, and it's both useful for the electrical engineers also. Again, it's advantageous to have knowledge of the power plant engineering, even if you are somehow interested or somehow working in some field related to the power plants. So this video could be useful to you, and in this video what I am going to cover is about the different kinds of power plants, the classification of the power plants. Then I will cover about the current power scenario in India, and then the power plant economics considering the different plant operating factor and etc. for the steam based power plant. Then I will cover about the different power plants like the thermal power plant or the steam power plant, the hydropower plant, the diesel based power plant, the gas based power plant, the wind, uh, the solar, etc. So all this will be part of a complete course, but I'll just, if you are attending this as part of a college lecture series, so it could be covered in around 10 to 12 lectures or even more, as and how it is structured in a specific college. So again, I'm not going into very theoretical details like the mathematical details and everything, but I will try to touch upon the important points and cover the full course in a period of like 40 minutes to give a quick overview, and which can be very useful if you are in for exam preparation, if you are into quick revision, if you have very less time, and if you want more practical knowledge or more insightful knowledge about the topics, then this video could be useful to you, and you could consider watching it to the full length. If this topics relate to you, you could find some useful information here. So again, there is a series of videos which I had previously prepared about the specific topics which are in more detail. So if you want to look into the topics in a detailed way, you can go through the playlist which is given in the description. So again, coming to power plant engineering, as I already prepared a video about the transformers and the working of the transformers. So the transformer was an essentially a very important tool in the power plant or the power systems. So earlier there were the DC systems, and then there came the AC systems. So what happened was that with the advent or with the invent of AC power systems, with the AC power systems invention was possible with the invention of the synchronous generator or the alternator. So it was possible to produce the electricity in three phase at a frequency or a synchronous frequency. So currently the frequency in India is, which we get the electricity, is 50 hertz. So based on that, you can again have something like the synchronous frequency, and based on that, the speed of the prime mover or the speed of the rotating machine for the generator is decided. So again, coming to like before in the DC system, what was that? It was not possible to increase the voltage. Like if you are having a generation at 11 kV, then you would have to transfer that to a location. Suppose you are having earlier kind of power plants were mostly hydropower plants. So if you had a hydropower plant and also thermal power plant, it was not possible to have it very much close to the place of utilization. So the distance for the transfer of electricity was very limited, as if you're transferring at the low voltage, then the I square R losses or the heat losses on the conductor will be large, and there will be large amount of power loss, and the amount of voltage which will be available at the end will be very less. And again, it's not possible to have arrangement. It's needed to arrangement to have equipments to work at low voltage. Since you have your fan, your television, etc., it's not possible to make those equipments to work at a voltage of 11 kV or a 400 kV, etc. So those equipments usually work at a lower voltage. And if you speak of equipments like mobile phones, computers, etc., these work at a voltage even lower, like a 5 voltage. So again, those times, and again those devices work on DC, but again you are using the rectifiers and the converters to convert that from the AC voltage to the DC voltage. But coming to the point was that earlier what you had was your DC system, and then one of the main reasons it was not possible to transfer the electricity to larger distance. So there came the invention of the AC power system, the AC generators, etc. And with the invention of the transformers, it became possible to step up the voltage. So whatever voltage you had, you could step it up to a higher voltage, and you could transfer it to a longer distance, like 1,000 kilometer or a 500 kilometer, etc., or even more. So again, that was a part of the transmission system or the transmission network. So that I will cover as part of the power system engineering. So that is a part of introductory course of power system engineering in electrical engineers or electrical engineering. So coming to the power plant engineering, you will need a power plant or a power system, which is also power generating station, which is also known as a generating station or a power plant, to generate the electricity. So usually the generation will happen at a voltage of 11 kilovolt, and it will be transferred, or it will be stepped up using the step up transformer, and then there will be a long transmission network which will be high voltage lines. So you would have seen the long towers or the high voltage transmission towers, as it is very common to see as you're traveling. Or again, there is a distribution network, which are the towers which are, or the distribution lines which are passing nearby your buildings, houses, etc. So those are the distribution network, and the longer towers are the transmission network. So in the transmission network, usually the voltage is very high, like it is a 400 kilowatt or a 700 kilowatt, etc. There's high voltage transmission. Again, there would be substations which will step down the voltage nearby the distribution area, and again there could be a different voltage given to the industries, and there could be a voltage which is used for distribution, could be close to 400 volt, that is a line to line voltage. So if you are familiar with the electrical engineering, you would having much understanding, like a line to line voltage will be between the two lines, and the line to neutral voltage, it will be between the line and the neutral. So that is, even neutral is connected to the earth. So again, the line to neutral voltage will be 230 volt. So that is the voltage which is coming to your house for electrification purpose. So again, coming to the power plant. So the power plant is a place where you are generating the electricity. So it's possible to classify the power plant based on the kind of fuel which you are using. So again, it works on the principle of law of conservation of energy. So it is what is that you are doing is that you are transferring one form of energy to the other form. So the energy forms which we are having, or which we are available to us naturally on the surface of the earth, is energy like the solar energy, the energy from the fossil fuels, like energy from the coal, petroleum, diesel, etc. And again, there is another kind of energy like energy from wind, energy from the geothermal, which is energy from the heat coming out from the surface of the earth. And again, there is a tidal energy. So based on these kind of different sources of energy, it is possible to use this energy to convert the energy in the chemical form, or convert the energy in the solar heat or radiation form, to what is known as a mechanical energy. And the mechanical energy will be the turbine or the rotating medium. So the turbine is a mechanical device, and whenever you are flowing some kind of fluid on the turbine blades, like steam, water, gas, etc., it will rotate, and whenever that will rotate, it will cause the shaft which is attached to the turbine to rotate. And whenever that shaft attached to the turbine is rotating, it will cause the alternator or the synchronous generator which is attached to the turbine to rotate. And the synchronous generator will always rotate at a synchronous speed, which is decided by the frequency which you are needing. So based on the frequency, the whole generation or design of the device will happen. Again, the speed of what you want for the turbine and what you want for the generator will be decided. So that's all as part of the design. So this is how a basic, and again when the electricity is generated you will have the full transmission network, and there will be the power transformers, etc. So coming to the different sources of energy, there would be the conventional sources of energy. This will be like the energy which energy from sources which will eventually get depleted. So some kind of sources of energy would be like the coal, petroleum, diesel, etc. Uh, so based on that, you could have the steam based power plant or steam engine based power plant. So steam engine is like it will rotate itself. It's a kind of engine, and again it was used during the earlier times, and nowadays we have moved something like a steam uh, turbine based. So based on the steam turbine, the coal is used to heat the water in a boiler, and whenever the water in the boiler is heated from the heat from the coal, it will generate steam, and the steam is using a nozzle. It is being thrown on the blades, and or it is made to flow over the blades in case of a reaction turbine, and whenever that will happen, the electricity will be generated as part of the process which I explained earlier. So again, there could be a diesel power plant. A diesel power plant works on the basis of a diesel engine. So diesel engine, it could be a 2-stroke engine, a 4-stroke engine, etc., or it could be a diesel power plant engine specifically designed. So whenever that the fuel will burn in the engine as part of the mechanical process whichever happens for the working of the engine, it will cause the shaft to rotate, and again that will be attached to the generator which will rotate and produce electricity. So diesel engines are generally used as standby power plants to supply for the peak load or for low load requirement. Also it is used for the electrification purpose of small buildings, etc., in case of as a backup generator, etc. And mostly it is not used as a main power plant. It is used as a main power plant only in rare cases where it is not possible to construct or have a coal power plant, etc. So again, the other kind of power plant is the gas turbine power plant. So in the gas turbine power plant, what will happen is that uh, instead of using, you will be burning some kind of fuel and hot gases will be generated, and this will not be used to heat the water in a boiler using tubes to produce steam, but this gas itself will be used in the form, and it will be thrown on the turbine blades. The hot gases, whenever it will be flowing on the turbine blades with high temperature pressure, and using the nozzle, it is possible to convert it to velocity, and whenever that is being done, the turbine will rotate and electricity will be produced. So that was the hydro gas power plant. And again, the other kind of power plant is a hydropower plant. So hydropower plant, there will be a dam, and subsequently you will be having the penstoke which will be bringing the water to the turbine, and again the turbine will rotate. So again, there is a lot of theory on how hydroelectric power plant works. And the final kind of power plant is a nuclear power plant in this case. And then there could be something like non-conventional sources of energy which will never get depleted, or which should be available for over thousands and thousands of years on the surface of the earth. It is estimated to be available. So some kind of such sources of energy is the wind energy. So the wind power is assumed to be available for a longer period, and it is one of the largest available form of energy on the earth. And again, the other kind of energy is the solar and power, which is also assumed to be available for a larger number of period and in abundant quantity. So it is possible to electrify the full all of the current equipments. It is possible to meet the full load demand using only solar and wind power. So I don't have any facts to validate this currently, but there is enough amount of energy available. If it is used, it can meet these the load requirement currently. So again, there is something like the thermoelectric, wave, tidal, etc. So this was about the classification of the power plant. So you understood about the classification of the power plant. After that, now you'll be wondering about, like, what I'm liking to talk about would be the power scenario in India. So coming to the power scenario in India, it's a situation where you are using something like the nuclear power, the solar power, the wind, the thermal, everything. And in India, the full of the electricity is connected using a national grid. So it's possible that electricity would be like there would be a thermal power plant in some kind of state, there would be three thermal power plant in some kind of a state, there would be one solar power plant because the geography would be very much suitable, and there could be a hydropower plant in some kind of a state because there would be a river flowing which would be very much suitable for building a hydropower plant. And it's even possible that some state is very much deficient in not having the kind of generation of electricity possible due to its geography or some other reasons. So in such case, it becomes very much necessary to have a transmission of electricity from one state to other. So all these are controlled by different state electricity boards and etc. But there is a national grid that connects all the different electricity or generating stations in a city, in a state, or in a country, so that the transfer of electricity from one state to other, or the so something just happened, I got a message something, so my camera just stopped. So what was it that was national grid was what is connecting the full different states or different power plants in the city, so that power sharing between the different zonal grids and etc. is possible. Also the state power sharing between different states is possible. So again, the capacity of the national grid as per the 31st Jan 2018 in India is 334.4 gigawatt. This is a detail as per the Wikipedia website for the electrification in India. So I have shown it just here. So again, coming to some other facts which are recent from that same source, like the coal power constitutes around 58% of the current electricity generation in India as of January 2018, and the large hydropower plants constitute close to 13%, and wind power constitute close to 9.8, while solar constitute close to 5.1, and the nuclear, which is a little bit on the lower side, constitute close to only 2 percentage. Again, there are different electricity boards like the National Thermal Power Plant Corporation and the National Hydropower Plant Corporation, which controls most of the hydro and thermal power plants in India. So yeah, and the current power scenario in India. And again, when you are talking about power plant, you need to know something about the power plant economics. So what the purpose of a power plant, suppose you are imagining that you have only one power plant and you are having a very small state or a city, and that city is independent, it is not connected to any of the grid or etc., and you are just using one kind of a thermal power plant to supply that amount of power which is needed for that city. So what will happen is that before the power plant is even being designed and everything is being done, you need to see what will be the load of my that city. So there would be like the population could be like over 1 lakh or 10 lakh. There could be hundreds of houses, there could be thousands of houses, and there could be the people could be having all the daily equipments etc. There could be 10 or 20 factories in the nearby vicinity of the city, and there could be different commercial centers like shops, malls, residents etc. So all these will be needing some kind of electricity, and what all this kind of electricity which is needed is known as the connected load. So what all equipments are connected to my power system is known as my connected load, and it will be drawing some kind of power in kilowatt. Suppose I simply imagine that I have only my house is my connected load. In that case, what will happen is that I would be having a 4 number of fans, a 2 number of television, a refrigerator, the AC, etc. And in such case, my connected load would be in kilowatts. Each of, if I total my television is drawing a 40 watts, my fan is drawing a 50 watts, etc. I'm not sure, I have not seen that exactly how much it will cost, but it's possible that the connected load of a house could be close to 1000 watts or 2000 watts. So again, that will be the due to the equipments, and again that will be the connected load of my house. Again, what is my demand is will be that how much kilowatt is being drawn. So whatever, suppose my total connected load is 2000 or 2000 watts in a simple house case, but it's not possible to draw everything. So I would be having sometimes only two AC on one AC on while one is not on, only one television on or two fans on. So in such scenario, my load will be varying. So suppose my total load, which was possible, was 2000 watts, but it's possible that it will be keep on varying during the period of the day, and it will be varying around average point like 1000, and my peak could be something like 1500. So it could come during the period of the afternoon while it is hot and both the ACs are on. So in such kind of scenario, if you are considering it for a simple house, it's possible that the same scenario will be there if you add up everything for the full city. While it's also possible to add up the scenario where you will be having different factories and etc. So the load will be varying. So the graph of the load with the time is known as the load curve. So before you are studying the power plant engineering, you will need to know that what is my load curve. Again, there would be like something like the peak load, and that is the maximum demand which I said. So demand will be how much is drawn, and when you are plotting your demand with the time, you are getting the load curve. And during that load curve graph, you will have something which is the peak, that is known as the peak demand. And again, the demand factor is the maximum demand divided by the connected load. So the maximum demand, that was my peak load, divided by my connected load. So just in the example which I said, my peak load was at 1500, but my connected load was 2000. So 1500 divided by 2000 will be my demand factor, and again this will be less than 1. And the average load is that the area which you are having under the curve. So if you are having a demand of 1000 for at 9 o'clock in the morning, and again you are having a demand of 1200 at 10 o'clock, so you are having a varying graph. And if you are plotting, if you are averaging that divided by 24, you will get your average load. And when you are having your average load, it's usually possible that your maximum demand was 1500 and your average load will be close to 1400 or 1300 in the just the example which I am taking. So it's possible that your load factor will be always less than 1, that is the average load will be less than the peak load, and it will be always less than 1. And it is possible to have a load factor as high as possible, that is the average load should be as much close to your maximum or peak load. The reason is that if you're talking about large power plants, there would be always need to, the power plants would be designed considering the average load. So if I'm having a large system, then if I'm taking that I'm designing my power plant for 100 kilowatt of supply. So if I'm having a peak demand of 150, then I would have to keep that 150, because that demand is happening only for a period of 2 or 3 hours in a day. So it will not be economical to run my power plant for 150 kilowatt for the full 24 hours. One of the reason is that you can't store the electricity and it will get wasted, and there is no utilization happening. So your efficiency of your power plant and the plant operating factor and everything will go down. So what will happen is that you need to have a standby generator or a standby power plant to supply that kind of peak load. So that is a need why you need a load factor as close to unity as possible or as high as possible. And again, why you this will be considered or should be considered as part of the designing process of the power plants, etc. And again, there is a capacity factor, which is the average load divided by the plant capacity. The plant capacity is the maximum which the plant will be able to produce if it is loaded fully. So in just the example, I said that if my average load was close to 1400 and my plant capacity and my connected load was close to 2000, and my plant capacity, if I'm saying it's only 2000, then 1400 divided by 2000 would be my plant capacity. But since my average load is close to 1400, I will never run my power plant to 2000 watts in this case, just a small power plant or small generator if you consider. could be in kilowatts, it could be in megawatts for larger systems. But I would be running it close to 1500, and I would be having a backup generator or a backup from the grid whenever I will be needing that 500 extra, if in any case. So that was all about the load curve. And again, based on the power plant economics, like there would be, if you are having a simple power plant, there would be something like the cost of the power plant would be like the cost of the fixed cost, like cost of the construction, building, equipment, etc., then the interest, depreciation, and insurance, management, fuel, etc. And based on this, you are deriving the tariff, which is a general form of tariff is Z is equal to AX plus BY plus C. So Z is your total bill for the period, X is the maximum demand in kilowatt, and Y is the energy consumed in kilowatt hour, A is the rate per kilowatt of maximum demand, B is the energy rate in kilowatt hour, and C is a constant amount. So this is just one of the ways with which you are having some kind of a tariff. So again, what we saw was that you will have your power plant, so you're designing your power plant based on all the factors like the cost of the power plant, the fixed cost, the operating cost, and the running cost, etc. You will be having, based on which the companies would come into an equation which will help them to derive the tariff or the amount which will be used to billing you. So it will be different for different countries, even for different states and electricity boards it will be different. They will be having different rules. So this is just a general form, and the equations which the different electricity boards would be using would be very much different from what is shown here. So after this, just coming to one of the power plants is a steam power plant. So I've discussed in detail about this different kinds of power plants in the different lectures which I have covered over the period of last 2 weeks or 3 weeks. But again, I will just covering a quick overview of what all are there in a steam power plant. So steam power plant will have a combustion chamber, and the combustion chamber will be the place where you will be supplying the coal, the oil, and the gas, or you could supply the air. So again, there would be the chimney for the exhaust gas, and there would be the boiler, and the boiler would be the place where you would be passing the hot gases which are coming out from the combustion. And the hot gases, whenever it is passing through the boiler, there would be tubes which would be connected to the boiler, which would one inside which the water will be passing. And whenever this hot gases and the water will come in contact with each other, the water will get heated and it will get converted to steam or in the vapor form. And whenever it will convert to steam, this water at high temperature and high pressure, the pressure and the temperature of the water would be increasing. And whenever it is converted from high temperature to high pressure, this water would be thrown on the turbine. So it can be thrown on the nozzles, using the nozzles by converting the high temperature and high pressure to water at a high velocity and pressure. So again, it is possible to do that, and while it is working on the turbine blades, the pressure will again get reduced. So that's one point. Also, when you are throwing it directly on the turbine blades, it is known as the impulse, and when you are making it do a kind of a reaction, you are making it to flow in a large quantity without and making it to expand on its own, it's known as a reaction. So there are two kinds of turbines, one is the impulse turbine and one is a reaction turbine, which is possible. And again, you will need to condense this steam so that it can be fed back to the boiler for heating. So that is also done as part of the condenser process. So you will need to have a condenser also, and it will be, this turbine will be connected to a generator which will be rotating and will be producing electricity. So coming to a simple parts which is possible, you will be having your cool handling plant, you will be having your boiler, then you will be having some other kinds of equipments. As you can see in this diagram, will be a superheater. So superheater would be again using the flue gases before it is being passed to the chimney. So whatever it will doing is that it will increase the temperature of the steam to a higher level so that the power plant efficiency would be increased. Again, there would be an economizer. So economizer would be used, again it would be using the flue gases or the gases which are flowing in its way to flow through the chimney. So you will be using that heat to increase the temperature of the water before it is being supplied to the boiler. So again, you are increasing some sort of efficiency there, and again you can increase use a air preheater using the same flue gases, so that the temperature of the water is increased before it is being supplied to the boiler. So these are the essential parts of steam layout for a steam turbine or steam power plant possible. This is using the coal as a fuel. Again, this will be expanded on the turbine, and you are having the condenser to cool the water. So it would be in steam form, so you are cooling it so that it can be supplied back to the boiler. So that is being done. So that's a simple layout for thermal power plant. So if you are talking about what I just said was about the thermal power plant and all these kind of power plants, whether it's a thermal power plant or whether it's a gas-based power plant. So both these kinds of power plants would be, whether if it's a thermal power plant, it will be having the steam as a fluid. Whether if it's a gas power plant, it will be having a gas as a fluid. So whether it's a thermal power plant or whether it's a gas power plant, what will happen is that it will be working on the thermodynamic cycle. So if you see, there will be a steam generator which will be generating the steam, and this steam will be with the pressure will be increased from A to B, and that is when it is being acted on at the steam generator. The coal will be the fuel, and based on what is used to generate the steam is the hot flue gases or the hot gases coming as part of the combustion. And again, the temperature will be increased, so the pressure is also increased, the temperature is also increased in the combustion chamber or in the steam generator. So again, as you can see from C to D, what is happening, this is an Rankine cycle. So what is happening is the expansion. So the full steam will be expanding on the turbine blades. So whenever the expansion is having, the pressure is also getting reduced, the temperature is also getting reduced. So when it will expand on the turbine, that will be converted to the kinetic energy, or the rotation of the convert to mechanical energy. So it's possible to convert it to kinetic energy using the nozzles. So that will be the impulse turbine, and it is possible to directly throw the steam on the nozzles using the increase the pressure of the increase the kinetic energy of the steam, and directly throw it on the blades of the turbine. And also it's possible to have a case where they can have a reaction, and you can make the steam expand on the turbine and do the work itself without converting that first to the kinetic energy. So that's the difference between the impulse and the reaction turbine. So this is a basic cycle on which most of the power plants will work. Like it could be the vapor based or a gas based. So again, there could be multiple scenarios possible here. There could be reheat, you could use a superheater, so you could be using the preheater, so etc. could be shown in the graph, and it could lead to like regenerative cycle, reheat cycle, binary vapor cycle, etc. So these are the different kinds of power plants. Again, if you are talking about the diesel power plant, so diesel power plant will have a diesel engine. So it will, in the basic, it will have a diesel engine, and what you are doing is that you are supplying diesel as a fuel, and so this engine will will produce, the shaft will rotate like your engine of your car or engine of a bike is rotating. In a similar way, the mechanical energy will be converted to the chemical energy from the fuel, which was the diesel, will be converted to the diesel, and chemical energy will be converted to the heat energy, and the heat energy will produce the work, and the work will be converted from mechanical energy to electrical energy via the coupled alternator. So some of the important parts is the fuel tank, there's a diesel engine, so diesel engine is there, so again there is a cooling cycle, and the generator will be coupled. So this is just a simple layout of a diesel engine possible. So again, the engine could be 2-stroke, and there would be like the fuel tank, cooling tower, etc. And coming to the hydropower plant, so this is again one of the important kinds of power plants. So what you are having in the hydropower plant is that you need something to store the water. So you are constructing a dam, you are having a catchment area, so the whatever is coming on the outside of the dam is known as the catchment area. The catchment area is the area surrounding the dam from where the water will be flowing. The water will flow from the catchment area to something known as a reservoir. So reservoir is a place where water is stored behind the dam for a larger period of time, and the dam will have its gate, and the gate will control the amount of water which will be flowing to the turbine, and the amount of water needs to be regulated based on the load which you are having on the or the load requirement. So based on the load requirement, it's possible to have a different kind of or a lower amount of electricity generation. And again, there is a draft tube for the exit, and the turbine here in this case, the hydro turbines are the impulse turbine, which is a Pelton wheel turbine. So again, like the steam turbine, the impulse turbine, the pressure energy will be converted to the kinetic energy, and it will through using the nozzles, and it will be made to hit the buckets or hit the blades of the turbine, which will cause the rotation of the shaft of the turbine. And again, reaction in the kind of reaction turbine, which is the Francis and the Kaplan turbine, simple examples. So the full amount of water will be made to flow over the turbine blades, which will cause a kind of a reaction which will cause the turbine blades to rotate. So the Pelton wheel or the impulse turbines are used where the head is high. Whenever the head of the turbine is high, it is possible to have a large amount of kinetic energy. While if the head is not low, like the dam height is less, it's possible to store large amount of water. But since the length of the tube which is carrying the water from the dam to the turbine is less, it's not possible to get that amount of kinetic energy. So you will need some kind of an impulse effect and a reaction effect by flowing large amount of water of the turbine to produce a large amount of electricity. So that was just a basic, like how this full hydroelectric turbines and hydro electricity could be generated. So again, there would be the powerhouse, there would be the generator, etc. in this case, and the tailwater would be, there would be two important components, like there would be spillway in case of a hydroelectric power plants. The use of the spillway would be to divert the water, excess water, in case of a situation where there's a heavy rainfall and the dam is getting overflowed, etc. Or to divert the water in case of a maintenance, etc. If needed, it's possible in such cases to have a diversion path. It's not a spillway, and there's a water which is flowing after it leaves the turbine. The water will flow through something known as a tail race. So tail race could be connected to the downstream of the river, or it could be connected to a canal, etc., to divert the water after it does the work and leaves out of the turbine. So again, the other kind of power plant is you could have a wind power plant. So I have not made a lecture specifically discussing about the wind power plant, but coming in this series, so the wind power plant will convert the kinetic energy to the wind energy. So the wind power plant will be working based on the asynchronous generators. So the asynchronous generators will not be able to work on the synchronous speed. One of the reason is that the speed of the wind is keep on changing. So based on that, it's not possible to generate electricity at a very much fixed frequency. So again, you will need, so there will be the turbine and the blades, there will be the shaft, there will be the generator, and it will be converting from DC to AC. So you will need to store that energy and convert it from DC to AC. One of the reason is that a frequency, you will need it at a fixed frequency to supply it to the grid or supply it to a nearby village, house, etc. So the wind turbines, again, there would be large blades, and one or two or three blades are usually there. So these will be very large construction, and there could be a wind farm, there would be multiple wind turbines or working together to produce a large amount of electricity. Again, this could be horizontal axis, or it could be a vertical axis wind turbine. And most of the wind turbines used for electricity generation are horizontal axis wind turbine. And again, the next kind of power generation possible is using the solar or photovoltaic cell. So to generate electricity from solar photovoltaic cell, you'll need a PV arrays or photovoltaic arrays. So you'll need multiple photovoltaic arrays, and if you're into generation of a large amount of electricity, you'll need to connect these photovoltaic arrays to cause a large solar farm. So multiple solar arrays will be connected, and it will be forming a DC to, you'll need a DC to AC inverter. And so the electricity produced from the photovoltaic cells would be in the DC form, and usually the energy produced by each cell will be very large. So you're connecting different cells and you're producing a large amount of DC power, and you need an inverter to convert that to the AC power. Also, usually that energy is stored in some form of DC power banks. It is possible to convert that to the AC power whenever needed, but it is not possible to store large amount of energy using power banks, as it is not economical to have large DC power banks or DC batteries in to store the electricity. So it is converted to AC and it is supplied to the grid, or it is being supplied to be used. But again, the solar power will be not available for a period of 24 hours. So if you are only relying on the solar power, so you will need some kind of a storage to supply for you for the amount of power needed by the time during time when the solar power is not available in form of the solar energy. Again, it's possible to supply the excess power to the grid if you are having a solar installation, and it's possible to get subsidies from the government for the excess you are supplying. So it's not available, I'm not sure if it's available in India, I'm not checked that, but it's available for some of the countries. Again, it gives you a sense of independence in a sense that you can produce and use your own electricity. So it's possible for people to use in small rural and urban areas. Even if you are having such kind of arrangements possible in your house to install solar panels and use that, it will save you electricity. Even it could give you backup power in case you are needing that. And the next power plant which I'd like to discuss before closing this series of lecture is about the gas turbine power plants. So the gas turbine power plants, the fuel would be the gas which would be obtained from burning high octane gas or heavy diesel oils, etc. So there would be a combustion chamber in which the burning will be happening. You need to supply the air, and the air would be usually in the compressed form. The pressure would be increased before it is being supplied, and whenever it is burning, the hot gases will be flowing, made to expand on the turbine blades, which will be causing the electricity generation. So the efficiency of these kind of power plants are usually in the range of 20 to 30, while the efficiency of steam based power plant is a little bit larger. So again, steam based power plants are used where it's not possible to have a coal based power plant or thermal power plant. Also, it is used as a backup or peak load power plant in most of the cases. Again, it could be open cycle based or it could be closed cycle based power plant. So one of the reasons of having a open cycle based power plant is that the air, every time it will be the fresh air which will be from the atmosphere will be taken, and the exhaust will be lifted back to the chimney. But in a closed space cycle, gas power plant, you will be having the same air, which is the hot air, you will be making to circulate it again and again over the power plant. So as you can see in the diagram, so this is just an introductory course, and why I want to make this introductory course is that I wanted to make a large video. So to sum up, so if some people are interested to get more knowledge, like they want to have this instead of going through 5 to 10 videos, you got an overview. So I will not be preparing this kind of videos for all the topics, but whichever topics, like I have much of the time right now, so I have time to prepare this kind of videos again. So instead of watching this 10 videos or whatever quick knowledge, this could be useful to you for exam preparation, etc. In a period of like 50 to 60 minutes, you would have got the knowledge of what you needed in a 10 to 6 lectures. So again, this is not a substitute of what could be like what the knowledge you would get from your books. So again, you need to read your books if you're preparing for the exams. But if you are again like needing the full playlist of the videos I have given in the description. Also to like, subscribe and comment. Next I'm going to prepare a video related to the exam preparations, like how to prepare for your exams if you are a less amount of time, like 10 days, 15 days, even how to prepare for your exams. Is it possible to prepare for your exam uh, during a period of 1 week or etc. So again, I will be discussing about the RRB exam, which is recently launched, and some of the competitive exams I'll be discussing after this. And I'll try to cover something about the power system engineering or some other engineering topics possible. Also, I'm not in the series of lectures. I'm not gone into the theoretical details or derivations. Again, these derivations happen as part of designing or operation of the turbines. So there will be specific derivations for the operating of the turbines, etc. So if possible, I'd be covering that also. Also, some of these things which I have not covered was about the regenerative and the other multiple cycles possible in the gas turbines, etc. So if I'm getting good response for this series of videos, after some time I may add upon those series of lectures in this same playlist. That's all.